So let's say you have an idea that will generate the following cash flows. The project will cost $20,000 this year, then will produce positive inflows of $4,000 per year for 7 years. How would you evaluate the financial attractiveness of this project? There are generally 3 quantitative metrics that are used here. The most common of these is called payback. This describes the amount of time it takes for the project to recover its initial investment amount. So in our example, with an initial investment amount of $20,000 and then $4,000 coming in each year for 7 years, it will take only 5 years to break even or have the project pay itself back. Pretty straightforward, right? Well, let's see. Let's say we have our first project with the initial investment of $20,000 producing $4,000 a year for 7 years. We know the payback for this first project is 5 years. Now let's add a second project with an initial investment of $60,000 that produces cash inflows of $15,000 per year for 4 years. It is clear that the payback for this project is exactly 4 years. So to review, the first project has a payback period of 5 years, and the second project has a payback period of 4 years. Which one's better? Obviously, the sooner the better, right? So the second project is better than the first project, right? Well, it's not quite that simple. If you think about it, the second project barely recovers its initial investment with nothing left over. $60,000 investment, project gives you back $15,000 a year for 4 years. Plus a $60,000 initial investment is a lot more money than the $20,000 the first project requires. Also, the first project keeps producing cash flows even for a couple years beyond the payback horizon. So you may indeed prefer a project with a longer payback. This is a measure that's very common because it's easy to understand and estimate, and it's a useful indicator of a project's liquidity. That is, the ease at which operations converts to cash flow. You may notice, however, that there are some drawbacks to this measure. In the above example, it's not clear what the benchmark is, and it may not work well to compare one project with another one. Also, although it's an indicator of how much time it takes to recover the initial investment, it doesn't say anything about the project's profitability. Moreover, a project's payback doesn't consider cash flows beyond the payback period. Remember that the first project keeps producing $4,000 a year for 2 years, beyond the year 5 payback threshold, and there's no consideration for that. Or say you have another project that has a large cleanup cost at the very end of the project's life. This wouldn't necessarily be considered, which is clearly a drawback. Finally, payback is missing one important characteristic. It does not consider the cost of financing. Let's go back to our first project with the initial investment of $20,000 and the 7 inflows of $4,000 each year. Say the $20,000 is received from someone who requires a rate of return of 10% per year. If that's the case, and you're really renting their money each year, then the future inflows from the project not only need to pay back the $20,000, but also the $20,000 plus the 10% per year. So to deal with this, you need to adjust the future inflows to calibrate them to today's value. And this would allow you to compare apples to apples, so to speak. This involves a concept called the time value of money. Let's turn to a separate example. Say I lend you $1,000 today and charge you an interest rate of 15% per year. You take the $1,000 and invest in an idea that turns the $1,000 into $1,100 in 1 year. In one sense, the project definitely paid for itself. But if you went to return the money to the investor, you would be short, as the investor would be expecting $1,000 plus 15%, or $1,150, and you only have $1,100. If you want to adapt the payback criteria to accommodate investor expectations, you need to find today's value of the future cash flows before computing the actual economic payback time horizon. So say this new project has an initial investment of $1,000 and the investor requires 15% per year. The project has forecasted cash inflows of $500 per year for 3 years. If you estimated payback the way we did before, it would be 2 years exactly. But this doesn't count the opportunity cost of the money. To do this, the first step is to find the present value of the future cash flows by discounting them by 15% per year to get their value in today's money, so to speak. To do the math, you simply divide the cash flow by 1 plus 0.15 for each year. So the first $500, you divide by 1.15 and get $435. The second $500, you divide by 1.15 twice because it occurs in year 2 and get $378. The third $500, you divide by 1.5 3 times because it occurs in year 3 and you get $329. So to sum, your initial investment occurs today and is an outflow of $1,000. The set of cash flows you expect to get in today's value are now $435, $378, and $329. Now, if you recompute payback using these values, you get a number, if you interpolate, roughly halfway in between 2 and 3 years. In other words, after 2 years, the project returns $813, so you still need about $187 to recoup the initial $1,000 investment. In the third year, you're expected to get today's equivalent of $329, so since 187 over 329 is about 0.56, the technically correct discounted payback is 2.56 years. Compare this to the 2-year payback without accounting for the discount rate. This roughly half-year difference may not be critical, but it is important because if investors expect a higher rate of return, this difference will get more pronounced and more important. In my experience, smaller and younger companies usually employ the traditional measure, whereas larger companies that operate in high-risk areas elect to employ the more complex discounted payback measure.